Well, greetings, everybody. So here's a problem from our quiz, and it's a related rates problem. Somebody asked me about it, and I have all the work to solve this problem right here, but I won't be emphasizing the same things that I normally do as far as what the rules of derivatives are and some of the algebra that's needed. That won't be the emphasis of this video, even though that you see it all right here. What I want to talk about more is uh, where you decide your starting point should be in order to solve this kind of problem. Now, if this video is not what you're looking for, or it's not enough for you, or you need help with the rules of calculus for derivatives and so on, then you can always look at the other related rates problem videos that I have. Okay. All right. But here's how I want to talk about this one. Short summary of this scenario is we have a boat and we reel it in by a rope right here. We reel in 1 foot of rope for every second that goes by. Okay, and that causes the boat to move on the water, and it will cause this angle to change. And the question is about each of those things. So part A right here, it says, well, I mean, basically, how fast is the boat moving on the water if the rope is reeling it in at 1 foot per second? So just because the rope's reeling in 1 foot per second doesn't mean that that's how fast the boat moves on the surface of the water. So let's do like this. I've got this. I'm going to conceive of this problem with the boat and the rope and the water as a triangle. I labeled the sides, 10 here. That one's constant, r here, x here. And I have dr dt is -1 feet per second because this side of that triangle, which represents the rope, is getting smaller, hence the negative, by 1 foot per second. Now, part A, think of it like this. I know dr dt. I know how fast the rope is being reeled in. And I want dx over dt, meaning I want to know how fast the boat moves on the water. So remember I said that the objective of this video is to decide your starting point. So where do you start in order to solve that problem? Well, I have to find some equation that relates r, because I know something about the rope. I know how fast the rope is being reeled in. And x, because I want to know about this side, which represents how fast the boat moves on the water. So I need, as my starting point, I need an equation that relates both of those things together. So look at that triangle. Is there such an equation? Is there an equation for a right triangle? This is a right triangle right here that relates the x and the r. Okay, because if you can find that equation, that'll be your starting point. And that equation is the Pythagorean theorem. Okay, so that will be our starting point, and we take the derivative with respect to time of that. All right. Okay, so now, like I said, that won't be the focus of this video. Here's all the work for the derivative. We put in the known values. It was given that r was 26 feet, so that has to go in at some point. I have to solve for the x under the condition r is 26. I can do that out of the Pythagorean theorem. I get 24. So all those values go in, okay? And we solve it. All right. Now, in part B, I'm have a different objective, okay? So in part B, it says, at what rate is the angle changing? Now, you could probably imagine that if you reel in the rope right here, the boat gets closer to the dock and that angle collapses, okay? So that's what this question is about, part B. Now, so think of it like this. I know dr dt, reeling in the rope at -1 or 1 foot per second. I just found dx dt, so I know that too. Part A, I found it to be -13 over 12 feet per second. I also have that r is 26 and x is 24. And I want d theta over dt. So to decide my starting point, I ask myself the same question. Is there some equation that would be applicable to this triangle that relates the things I have to the thing that I want? So, is there an equation that would be true and applicable to that triangle that relates r and x and theta? So if you can think of an equation that relates those things together, then that will work, okay? Now, the one I thought of for the purpose of this video was that sine theta is x over r. That's true, right? Sine of an angle is the opposite side over the hypotenuse. So there I have it. an equation that's true and applicable to this triangle, and it relates the things I have together with the thing that I want. All right, so that could be my starting point. Now, with that equation at hand, I would have to take the derivative with respect to time. With the rules for derivatives, I'd have to use the quotient rule in this case. I have to put my known values in. And there's quite a bit of arithmetic to solve this one, but I get negative 5 over 312. But remember, although I'm happy to help you with this part, I wasn't the focus of this video. Okay? All right, so that's our answer to B. Now, is there another way though? Like, do I have other options? Because all I said here was, is there an equation that relates r, x, and theta? Because those are the things I have and the thing I want to find. But in this case, this isn't the only equation that relates those things together. There is another way. All you need is an equation where you can take something you know to find out something that you want. Okay, so why not tangent? So tangent of that angle is opposite over adjacent. I could use that. It doesn't involve r though. Well, it doesn't matter because look, do I know something about x? Yeah, I know dx dt. And do I know this other side here? Well, yeah, it's 10. And then that brings theta into the picture. So I could also use tangent. I think it's easier to do it that way. So yes, this equation will also work. It's true about that triangle, and it involves something I know, meaning the x. I know what dx dt is. I know that x is supposed to be 24, and the thing I want, theta. So I could use that one too. So this is, we're not forced into this option. There are other options. So here's tangent theta x over 10, a true equation about that triangle that ties everything together that I'm working with. Taking the derivative, I get like so, and I solve and I get the same answer. Okay, it's a little bit easier to work through in this case. Now, so there you have it. I showed you two ways that you could do part B. Now, that was my objective with this video, is just to show you that, yeah, we want an equation that relates the things we have to the thing we want. But it doesn't mean that there's only one option for that. And in this case right here for part B, I show you two. Okay, I'll see if you can think of some more and try to solve it. And this could be true for other problems. It might not be true for every problem you see, that there's multiple equations you could work with to get your answer, but just let this be your principle. Just try to look at your situation and find something that relates everything together in the way that you need it to be.